Alright, and we are live. And I forgot to set up the stream elements overlay again. And actually make sure that was working. Because I want both. Let's see. So I want both streams to be able to see the chat of the other one. So let me just handle that real fast before we get into probably the most boring part of the language, and that's going to be how to handle native operators and whatnot, because, well, not necessarily boring, it's just going to be an absolute pain to implement. Yeah. Okay. So can I just duplicate this? I can. We're gonna rename one of these to YouTube Elements Overlay, and then we'll make it's the same one. Dang it, they're linked. Then and copy. Okay, so theoretically that's a chat box now. Okay, it is. It's just super tiny. actually throw it on the webcam. That way it's kind of easy to see. There we go. We now have chat. All right, now back to the actual stream. Or not. YouTube chat still isn't working. I'm not going to worry about it too much. Yeah. All right, so picking up where we left off, we're basically making it so that we could construct a abstract syntax tree out of document context nodes. So right now a problem is that all casting and native operators are done but there's not actually anything in the document context to support them. Meaning, you know, you're just left without, well, the way that I would, dang it, Brane has not been braining recently. I am tired. Anyway, so we would have every single type of operator or cast, and it's just a function call context, and then I store the signature of the function call or cast, because, you know, casting and operators can be either user-defined ones or native ones, and we don't have anything to differentiate them, so it's a little bit hard, because I would literally have to, if I kept it this way, in this AST function, I would have to search through every single one of these different possibilities and create something to support them. And that's not something I want to deal with right now. So what we're going to do is create native operator nodes and native cast nodes for each one of those things that will be able to kind of modularize that more. And then the way that we'll actually choose between them is, instead of like doing a set or function, instead of doing it the way I was doing it before, instead we'll have like a static function member of the struct that will just, like, we can pass it a couple of arguments and it will tell us, is this particular context viable for this operator, essentially. And I can already tell I need to drink some water, so I'm gonna go do that, because my voice is dead. right. Hello, how's it going? Just kind of getting prepped, as I should have before starting the stream. Thank you, I feel greeted. Alright. Starting off, let's just take it easy on ourselves and start out with a... Actually, no. Not starting out easy on ourselves. We're going to go straight for the native cast context. Like that. This is not a function. C++ specifically, probably about 3 years, but I've been coding just in general for longer than I can remember. I think it's about 3 years. C# a lot longer than that, so C-style languages for a bit while longer than 3 years. Yeah, it's a little bit of a leap, but once you get used to just like the different syntax for pointers and references and how it all kind of works on behind the scenes, I honestly prefer it, though I still really enjoy C#. Hello, how's it going? I'm trying to not utterly wreck my voice this time by actually drinking water. I think I should probably sleep more too. That might help my voice out more than the water. But what you gonna do? Oh, nice. Yeah, I don't know how much help I can be of there. I'm more so on the just straight up building of things. I mean, I try to make them secure, but it's not my specialty. Oh, nice. Let's see, Internet of Thing. That's just stuff like smart devices and whatnot, right? So, stuff like just making sure, you know, keeping devices on separate networks and whatnot. Yeah, it does seem like Unreal Engine is becoming a lot more popular in the past couple of years. Ever since Unreal Engine 5 got released, is really when that started to seem to happen. I think it's an amazing engine with a lot of cool out-of-the-box tools. For my personal work, I do actually prefer Unity just because that's what I'm more so used to. And I mean, obviously, I'm making my own game engine. I do think Unreal Engine gets overhyped a little bit just because of, post-processors on by default and whatnot. I don't think it's a bad engine, though. I think it's actually a very good engine. Oh yeah, definitely. It's like, let's take this engine capable of rendering just open world games in photorealistic quality and use it to make a pixel art roguelike. Though I don't think too many pixel art roguelikes use it. People generally tend to use a lot more Unity for that because, to be honest, it is the much better option for anything to do with 2D. I've experienced that too whenever I've played around with it, just because you do have to deal with the C++ compile times. Alright, this is where the fun's going to be. Right in there. So I am going to copy this absolute behemoth of a function. And it's what we're going to just convert to LLVM, basically. So we switch on the target type. It's an internal reflection system. I'm not sure it would have internal reflection because reflection is, as somebody who's written their own entity component system based off of like a jank reflection system, I'm pretty sure they wouldn't be using reflection. It might be templates, to be honest. Lots of templating. I know that can slow stuff down. And it's also a huge engine. Linking might take a while. And to be honest, I have no idea. I am completely spitballing right now. So LLVM is this open source toolkit for making compilers. So it's like a bunch of modules, and you can bring in whatever you need to actually make your scripting language. I already had a fully working scripting language, but as it's something I want to build an actual engine with, instead of just like a learning tool to play around with, I decided it was probably better to switch over to using LLVM sooner rather than later, rather than my own jank custom stuff, because I wanted it to last. But yeah, LLVM modular compiler, we'll just say that. It's a library for making compilers. Oh joy, it actually is all in here. I was like, maybe it was getting references to something else, but nope, it's just all these lines of code. Actually didn't want to include these. Oh well, we'll just deal with it for now. All right. So I've been working on the scripting language for, I think, about 6 months now. And the game engine that I'm building this for, I've been working on for a total of almost 2 years. Yep. That's why there's, so this is, all these source files are source files for the actual scripting language. And I've gotten so far as like, we have templated functions in here. Like, it's not a toy language. Well, it is at this point. It's not like, it's almost it's almost over the line of no longer being toy language and actually being usable, which is what we're trying to get it to. After the whole LLVM refactor, hopefully we'll be able to, so right now, I'm only able to support, let me actually get an example. I'm only able to support ref types to structures, and I built the entire backend under the assumption that only structures would be references, even though I knew eventually down the line I would actually have other types be references as well. It's essentially pointers, but behind the scenes kind of hidden. So basically I'm having to do a ton of refactors to actually support other types being references. But after that's done, yeah, exactly like C#. Yeah, the idea for this language by the end is that it's going to be like C style with a little tiny bit of C# when it comes to how you manage objects. I'm not going to have a garbage collector or anything. Everything is going to be stack allocated when possible. Since my engine is entity component system based, all the bulk of memory allocation will happen in that entity component system, so we don't need to worry about like overflowing the stack or anything. And we won't need to allocate stuff on the heap manually within the language either. So that's kind of like the idea behind that. So no memory management whatsoever. Oh yeah. Especially if you take the route that I took. And instead of using a higher level something like LLVM, which is what I'm switching it to, I actually used this pretty bare bones library called ASMJIT, and it basically lets you construct functions using assembly language commands. So for example, like compare, I just do like the assembly language compare command. And then after that, we just do jump based on like jump above, jump not equal, jump below, and you actually emit the assembly code instructions itself. I don't suggest doing it that way if you want to get anywhere fast. As I said, this like took me 6 months to get to this point. I would suggest learning something like LLVM. But yeah, now instead of emitting raw assembly language stuff, we have to figure out how to cast types in LLVM. So that's probably going to be in the current, probably with Builder. Currently it is, come on Brane, 9:30. I have it set to like 24 hours, not 12-hour blocks, so it messed with me for a second. And I am a little bit tired at the moment because I've been, so my job, actually work at like this VR startup, so lots of coding there, and then in my free time I work on this, so yeah. Let me check. Let's bring up documentation. Yeah. Yeah. Yep. Alright, so basically, this is what we're dealing with. Oh, come on, is this... See, this is the intermediate representation for LLVM, but it's not the actual, like, API calls. But we can probably use this to guess at the correct way. So from unsigned integer to int32, okay, so we want a truncated cast unsigned int32 to int32. Would we be able to get away with just plain create cast? Would it automatically find the type? Hey, I very much appreciate it. Thanks for sticking around, man. Let's see. So this is... I really wonder if I could get away with it just... Yeah, see you around. Okay, So for create cast, we actually pass in a casting instruction, which means instead of having to rewrite the code for every single thing, we could VM instruction we create an instruction assigned integer to floating point. Okay, but what type does this return? Value 44. Oh joy. So we have definitions for this. Actually, let's see what the type of create cast actually is. Instruction cast ops. Okay. So now we just need to set this based on what values we have here. So this cast instruction. Actually, we're just going to rename this to cast type. So would it be truncation? So we have Z extension, I'm guessing sign extension? Yeah. Floating point to signed integer, floating point to unsigned integer. Oh, thank goodness. They have stuff for unsigned too, so I don't have to manually do both instructions. All right, so here we want to do a truncation. So for every single downcast, do that. Assign extending casts, 0 extending casts. All right, cool. So we want signed to unsigned here. So for this unsigned integer for int 64 to unsigned integer 32, truncation would be fine. For integer to unsigned integer 32, would we also want truncation for that? Just want to make sure I'm using the correct type, or correct. LLVM. I know I could just use the MOV, just move. So this is definitely a truncation. Is that a truncation? Technically it is truncating it. One direction. Is So let's just see assembly code. I mean, it's probably just going to be a move. Yeah. They're unsigned by default. Yeah, I know. Food type I-32. Cast. Okay, so this is just when you don't care about cast. Signed and... Oh, it's... Oh, no, never mind. It's both downcasts. Where are... There you are. We're breaking out the compiler book. Because I remember it having a section on casting. $127. For runtime environments, we might want the chapter after this. Is there a glossary? There it is. Didn't have one for casting. If I went for truncating cast, nope. Oh, maybe if I looked up tight? Okay, I remember happening across this. Probably not gonna help though. Yes, I know what the definition of piece. Okay. Alright, it's not there either. Okay. I guess for now, typecast. We'll just do byteWise cast then for if it is a thing of the same size, so we're casting 32 to unsigned 32. Cast type bit cast. If we're doing that from int 64 to int 32, we want to truncate that. If we're doing an unsigned 64-bit, adds a truncation as well. I wonder, am I constrained to only one cast at a time? So it's like, first we cast from unsigned to signed, and then down? I won't worry about it for now. See, for this, we want to cast floating point to unsigned integer. See this unsigned to unsigned, 0 extension. Actually, that's an upcast right there. Want to do signed extension there. Signed integer. To signed integer. In both cases, we might want to do a 0 extension here. Actually, both of these can be the same thing. All right, now for if we're casting to a float. So for both the unsigns, and then for both of the signed, just like that. And then for float 64, this is cast type, cast ops. Floating point truncation. And then down here, floating point extension. All right, the water's getting to me. I'll be right back. Alrighty, back at it. Just realized I forgot to ping my Discord. Alright, so for both the unsigned... Well, actually, can we just copy this? Yeah. Then we can just builder, create cast. Cast type. Value and the destination type. So if this is a reference, we're actually going to have to LLVM pointer type get. And then all of these take into account pointers as well. So, oh, it was just structs that we weren't taking into account before. Nice. So I don't have to worry about casting this to a pointer type or anything. If we are casting pointers, I guess. We shouldn't ever cast a pointer, though. create a cast. And we pass in the end type. And the value. Just like that. And that should be all we need to do for casting. Now, one thing to keep in mind. Is we need to make sure we're not passing any pointers to this function, and if we are, we want to actually dereference the pointer. Oh, keyboard. Okay. Okay, even a basic block can be a value? Wow. So we have constants, we have instructions are values, operators are even values. Then again, we're creating a DHG out of this, so it kind of makes sense. So is aggregate type will return, if it's an aggregate. So array is bflow double. So there's create load functions. Okay, let's check how we... No. So alloc A is to allocate on stack. actually, how... Oh, yeah, that's right. That's a pass, not an actual command. Okay. Oh. So here... Okay, what is alloc instance based on? Unary instruction. Okay. How do we store globals then? So we get our insert global, and this returns a constant. Interesting. Does constant just refer to a constant memory location? So this eventually goes back to value. However, we can now test if this is a register or not. So if we say load value here, what do you mean value isn't polymorphic? It publicly... Oh. Class of. So we can just... Are we able to say, if possible ref is a... Oh, is this deprecated? Yeah. is a alloc instance. S for stack, so this will be stored in global, it'll be stored in stack, just for debugging. Okay, so we now have at least two different types of modules. Library context, we also need to set I hate that with every fiber of my being. we go. We now actually store the globals, which is good. All right, back to the native cast context, I believe. We want the source value to always be a register since we're actually using the value. Otherwise, we want to keep it in referencing the memory form. So we're just going to do that to make sure the value is always a register. There will be a ton of redundant loads, but we will be optimizing this a lot, so. Rather, we're going to have LLVM optimize it a lot. See, we're getting into, just change the stream name, and we're getting into isekai levels of log names. But, you know, apparently that's how you win Twitch. You know, you just have the isekai length title. So we now have native cast context, and to give ourselves an idea, and to give us an idea, There we go, we now have deep copy implemented. So this structure is basically done. So now what we're going to do is just have a static bool valid native cast from value context so from casting from this to this, actually, see, there aren't really any Boolean casts, are there? Actually, no, that's not where I would have it. I would have it in here. Okay, the only Boolean casts are actually doing a comparison. Okay, so I didn't have a way to convert char's characters to integers. I should. but I currently don't. We'll deal with that later. So all of these scholar types Alright, so that should return true if we have defined, if we can cast between those types. Yeah. So now in the static analyzer, we just need to use native cast context in the place of function call context on occasion. So, is it cast? Now here's the thing. The way it currently works is through resolve function call. However, right here is where we want to differentiate between native and non-native casts. And the reason that we're using resolve cast here is because we also have a resolve function call function here. It takes in function call contexts. And we want to intercept the automatic casting. Yeah, cast context right here. And just kind of take that out of the equation. So we'll return an expression context, so we know for sure that it's going to be an expression. And we're going to resolve a cast from from this to this. So, if native cast context valid cast from return type to storage type, at the type context. I guess it makes more sense for it to be a type context. Guess we'll handle dereferencing somewhere else. If we want to automatically dereference stuff. About 3 years, but I have been working on C-style languages for a couple years longer than that. Yep, and now we're making a new one. Actually, we do want value context. We're going to change this back to value context. Yes. So I'm making one specifically for the game engine that I'm currently working on. It's not going to be too weird. It's going to be hopefully a pleasant mix of C and C sharp. So the static typing of C with the, well, and I guess of C sharp, with the lack of memory management for the user of C sharp. So basically people don't have to deal with pointers while writing C-like code is kind of the idea. And also the engine I'm building is kind of weird, so it makes sense to actually build out a custom like scripting runtime and well, script for it. Theoretically, simpler natural language. I'm not sure how to define simpler natural language. It'll be nicer than using JavaScript, that's for sure. So I hope I can make it nicer than TypeScript. Yeah. While TypeScript is a huge improvement over just raw JavaScript, because you can actually figure out what API calls are supposed to be, it's still JavaScript, just in a trench coat. It's a pretty common experience, you know. Once you start, you can't stop. Coding just kind of sucks you in. Nice. You're beginning to think like the machine. Yeah, syntax is basically, it's just a ton of practice. And then once you get enough of it, you can see the similarities between languages. And then it becomes easy after you've done it for a while. Ah, I know how that feels. Managing that really depends on finding something you... 10 different directions. My advice would be to find like one project you want to work on that you think you can do, or maybe one thing you're not sure that you're able to do or not. Because being able to do it is just really thinking that you can do it and then going at it long enough till you actually do it. And then just doing that project. That's how I learned, was just through personal projects that I felt like doing. Yeah, so you have to make sure to scope your projects so they actually, you know, don't take as long as mine do. I'm going on 6 months with this scripting language, and the game engine that I'm building it for, going on 2 years. So don't ask me for advice on sustainable projects. Oh, I don't have 6 months to focus, but see, my secret is that I just want to do it, but on the days that I don't want to do it, I just don't. So sometimes I go weeks without programming, and then I'll have like a 3-day period where I completely burn myself out and then like sleep for 2 days. Consistency over time, not consistency day to day. A good measure is like month to month consistency, like programming the same amount per month. 'Cause yeah, I have not been consistently working on this every single day. If I pull up my git commit history, it's not an accurate representation because I'm not very diligent about committing. I usually commit once I finish a feature, but Linux is weird about that. But like in the last year, you can see like there's sometimes I go a month without pushing anything. Other times it's like a full week where I'm pushing a ton. Yeah, so you see there's a lot of gaps. Commenting it's a weird thing, because if you write your code right, theoretically you don't need comments. Comments, you really only need them where the purpose of the code can't be immediately determined. Like if you have a function called add to and it accepts an integer, obviously it's going to, oh, GitHub comments. Okay, yeah, those do matter. Or they don't. It depends. It depends on your coworkers. Some people are super strict about their naming conventions. Other people, I don't have it on this boot, but if I was on Windows, I could bring up like the version control for one of the things I'm working on, and it's just like my commits are fix to the fix to the fix to the fix. It's okay. I work at a startup on crunch time, so you know, it's like it's the character. Yeah. Actually, I think it's fine if that pointer gets deleted. So yeah, this is Sea Lion. JetBrain editors, very nice when they work. I've been enjoying it a lot so far. Ah. Yeah. I have, well, 32 in it right now. So I can go a little ham on the RAM. I don't know if I've set this particular editor to use more RAM, but I know in the past I've set it to like use 4 times as much RAM than it is by default set to. Honestly, I might need to do that. That might be why it's being slow sometimes. Settings. I don't know where it would be though. Is it in general? I bet it would be in system. I think before I was getting like errors about it not having enough memory. And that's how I changed it before. Max size. Yeah, like currently it's 8 gigabytes. That looks like I extended that. We can bump this up to twice as much though. I have more than 8 gigabytes to burn on this. Okay, which screen did that spawn on? Or did it spawn on any of them? There we go. Twice as much RAM. Hopefully this will stop the highlighting from occasionally just ceasing to function. But yeah, it's a helpful thing to know about. Just the change memory settings. Speed. Though theoretically, the more RAM you can give it, the faster it will go, because otherwise it will probably dip into caching stuff on the hard drive, because it needs to save the data somewhere. But yeah. Okay. You can also turn on a memory indicator to actually say how much is used. Right now, not very much. Because yeah, right now it's only using 4 gigs. All right. What was I working on? Casting, that's right. So theoretically it should already be working. Resolve cast should already plop this node in there instead of this node. Meaning that we will now cast stuff instead of function calling stuff. And theoretically, something like the global variable tests. No. Operator tests. No, that wouldn't compile. Let's do a test though. So validation should still work. This should be fine. Let's grab a reference to this and debug. If we actually compile, that is. Which we probably won't. We're not going to. Because I have a bunch of pure virtual structures at the moment that aren't supposed to be. Yeah. CTX is one of the more standard. Actually, I think it is like the main abbreviation for context. Yep. So our problem is these structures have the unimplemented virtual function. For now, we're just going to have them expression error context. Yeah, for now we're just gonna have them return null. Congratulations. Guess I have to create one of these here too. Oh, nice. So it just like you just changed the couple values and it started performing? And the real question was it increasing or decreasing the memory that did it? Yeah, that would do it. I mean, it's not really something you could have predicted, though. All right, let's see which structs are. Here's the return context. This is one. I'm jealous. I wish I too had a 128 gigabyte beast machine. Fortunately, I only have 32. I could get it to 46? 48. 48 if I... if I threw in the extra RAM I had. Yeah, though I took the RAM out because my computer was crashing for no reason whatsoever. And I thought maybe it was the RAM that was doing it. It was not the RAM that was doing it. It was the graphics card, which... that was fun. Graphics cards deciding to blow up it is very fun, especially when it is expensive graphics card. All right, return context. This should be pretty easy. Context dot builder create return. Actually, if not, what do I call the value? Because this can be a null pointer for. So if not value, you're going to create a ret void. Otherwise, auto ret val is equal to value create AST context. And we also want to make sure that this is loaded into registers, so load value. Yeah, luckily it was still under warranty, so I could just RMA it. But I have a backup as well because, like, I code VR stuff for work, so it's kind of bad if my work PC doesn't work. Yeah. Luckily, it was just an RMA, and I had to wait a couple weeks. Ah, thank goodness. I don't need to specify types or anything. I can just create return with return value. Wonderful. Okay, which error? Where error? Let's just go down the list of errors. This will show us the AST context, add value. Ah, yep. We need this to be LLVM alloc inst. That is the name of the data type, right? Please be the right data type. It's not the right data type. Alloc instant. Alloc A. For allocating onto the stack. I'm not sure if they refurbished my old one or sent me a new one, but basically. Could have been either way. Did they send it back in the box or not? I can't remember. I think they sent it back in the box, but like the extra cable, like power cables it comes with, were missing though. So I shouldn't have sent those back with it. All right, so if context is the next thing. All right, we're gonna have to figure out how LLVM's implementation of basic blocks work. So you ready to have a quick overview of how optimizing compilers work for low-level languages? Control flow. So basically, when compilers, well, optimizing compilers, optimize stuff out, well, when they're creating the intermediate representation, because a lot of times they have this intermediate representation between the document and then the final machine code. This intermediate representation is usually, it's usually like a tree. And that's actually what we're creating here, the abstract syntax tree, AST. It was actually stored in a tree type called a DAG, which I can't even pronounce the words. DAG tree. A directed acrylic graph. Basically, it's a node, but they reuse nodes sometimes. Node tree, but the branches can reconverge. In each one of those nodes, yeah, abstract tree. So for example, all these nodes here that I've been messing with, it's a different type of tree. Pretty much, this entire project is a ton of forests. Like I had these ahead of time operation nodes that created basically it was an abstract syntax tree, but I wanted to be different, so I didn't call it an abstract syntax tree. We have these document context nodes, which are also technically a tree structure. We have, when I parse out the grammar, it creates a tree. But yeah, to give you an example of what one of these trees might look like, if I were to go into something like my object tests, and we just copy this code into that, you can see it breaks apart each one of these functions into like their, you know, their components. You can see like, oh, there's a function here. Here's its list of arguments. Here's like all these declarations for the types and whatnot. And this is how I actually read the code when I'm generating the document context, which I use for the VS Code plugin and all that sort of stuff. And it's also what we use to then translate it to the tree type that LLVM uses. Now, the other thing about LLVM is compilers, when optimizing, they use this thing where functions are broken into what are called basic blocks. I know it's a very ambiguous name, but basic block. And basically what basic blocks are I'm gonna stop right there. Each node of this block is like a series of operations that can happen without branching. So branching is anything like an if statement or a loop. So any code that's not using an if statement or a loop or a go-to statement is in one block. So they create like kind of this flow graph, and I kind of have to somewhat construct that for like if statements and whatnot, I think. Anyway, what are H files? So H files are, C++ was invented a while ago, right? So they have weird solution to stuff. The C++ compilers before used to be what are called single pass compilers, which means, let's say I have this function and I want to call it down here. We're fine because the function has already been defined. I think Python works in a similar way, but if I were to define this function underneath this function, I wouldn't be able to call it from this function. The way H files work is they're basically a list of all the classes and functions in those classes. And then whenever we do this hashtag include statement, it copy and pastes this entire text file into this text file. So when it compiles, it goes, okay, what's a AOT node? And then it references the copied and pasted in text above it, defining what an AOT node is, because it doesn't actually link to any documents outside. Yeah, kind of like modules. And then these CPP files, or .c files if you're coding in C, are what actually gets compiled. H files, well, technically, yes, they do get compiled because they're copied and pasted into the CPP files. What they're more so used as, it's called forward declarations. So declaring something before you use it. Declaring the signature of something before actually declaring the body. So you can like declare there's a function that returns a bool, has this name, takes two arguments, one's an int, one's a float. And then the compiler won't throw errors because it goes, okay, I trust you to define this function later. And then it complains and cusses you out if you did not, in fact. Pretty much. It's to help the compiler out. Now, if you want to have a lot of fun, put the actual definitions for things in the H file. Or create two H files that depend on the other H file, and you get a circular header dependency issue. The funnest issues to debug, because they're literally some of the only ones that you don't get a compiler error for the actual circular dependency. You get something completely random. Something like that, yeah. They're definitions for things. All right, so let's, nope. I'm not pasting whatever that was in my clipboard down there. What we're actually going to copy and paste is the definition for this function that we are going to override from the base class. Indeed. Circular header dependency is probably the most Googleable version of that. Let me just see if I get any good results for this. Yeah, there's not really a... It's just circular dependencies, not necessarily for header files. It's something you run into, and then you get to figure out how to deal with it. Okay, I know what the... So that doesn't actually cause a loop. And that's for... That's what these do. So these are what are called header guards. So this is what's called a compile definition. It's like a bunch of stuff that runs before the actual compiler runs, pre-processing. So if this symbol isn't defined, so if not defined, this symbol, define this symbol, and this if not defined includes this entire thing, end if. So between this end if and this if not defined, if this symbol is defined, basically it deletes all this text. Now, if you're using like a fancy modern day compiler, you can do something like this. And this does the exact same thing as the definitions, but a lot of people like doing this instead because it's the older way of doing it, so it's more likely to be supported by everything. So yeah, if you're using Visual Studio Code, it's probably going to do like a pragma once at the top of the file. True. Though I don't know if you're referencing the pragma or the if definitions. Both are super common, so it's not like, basically you check if you have either one, and if you don't have either one, you're like, oh no, that's why I have multiple declarations of this symbol. Yeah. Preprocessors are really fun. Especially when you get into doing preprocessor stuff like... I don't have any too evil of preprocessors in this document. In my game engine, however, in here, where is it? Actually, would it be in scripting? No, it is in here. Ah, here it is. Ah, look at these. Aren't they beautiful? Preprocessors are code that runs before the compiler runs that can, depending on the state of the compiler, replace some text with other text. So basically, I'm using this to automatically return vectors containing the types of member variables. so I don't have to manually define those functions. So I just pass in, like, if we find references to this, dang it, native types. So like right here. So I'm saying register this as a native ECS component with the name mesh renderer, a field called mesh with the name mesh, and a member called materials with the name materials. And then it grabs all of like the variable offsets and whatnot, so I can actually throw that into the entity component system. So yeah, sorry for pulling that out, but yeah, these can turn into much scarier things. But yeah, basically we have to... Fun is one word to describe it. An absolute nightmare to debug, and that because I was also using template metaprogramming in there, which is just look up what template metaprogramming is, because I actually need to get back to working on this. It'd be amazing if I could get to the point where we can generate LLVM intermediate representation. But yeah. If you're just barely learning C++, don't even try template metaprogramming. Definitely try out templates. Templates are cool. Templates are amazing. Template metaprogramming is black magic that I barely understand, but I still use. Basically, it's using... I don't even know how to describe it. It's using a language to write itself at compile time, basically. Okay. Programming a program that writes a program based on a template. Probably. In the case of the functions I was showing you, it was a compiler preprocessor that generated a template that then generated code that then was used to actually compile the program. All right. And I'm gonna get back to actually coding instead of flexing my knowledge of the dark arts. Okay, so that's how this works. Got it. Okay. So when we create the AST, to condition equals context create AST context. Oh, not context. We want if context condition. Is it true? And then there's a false. Would it just automatically detect? If the false was the continuation? Okay, so I have to manually connect. Oh. Ooh, that is a question. How do you have to know? Oh, do you have to know how to manage memory and hardware resources to program in C++? You need a basic knowledge of how stuff works. So actually, I can give you most of what you need right here. So let's say you have int a and a is equal to 1. This is allocated on what we call the stack. The stack is like local variables. They get deleted when a function ends, basically. And you don't have to manage those because they get deleted when the function ends. Now let's say instead you have a pointer. So pointer doesn't tell you anything about where a is stored. It's just a memory address, which you can then dereference to get the value that the memory address is pointing to. So actually, let's change that to B. So for example, I could change this to be pointing to A. So B and A are now essentially the... Yeah, so stack gets cleared when the function ends. So if I have a pointer B that is pointing to A, if I use the asterisk, not the asterisk, the star to dereference B, I'm actually setting the value of A here. B isn't able to store anything other than a point. It's like pointing to A. So you don't need to manage this either, because both of these are stored on the stack, so they both get deleted. Now, the thing that people freak out about when it comes to... Yes. And if you want to be fancy in C++, you can make it a reference instead of a pointer. So this is the same way that like a C# reference works, where you can actually pass an A. So B is now referencing A. So when you set B, it sets A. But we're not going to focus on that. That's like... It's like sugar. It's fancy. It's a pointer behind the scenes. But the thing people worry about when they worry about memory in C++ is when you use the new operator. So when you say new, this doesn't allocate on the stack. This allocates on the heap. So the heap, like we have the stack over here, which like grows as you call functions and then shrinks as functions return. New, it's over here in the what's called the heap. So it's in physical memory, it's on the complete opposite side of your RAM. So if we say new int and we like initialize it to 3, B is no longer pointing to A, it's pointing to this int that we have created off in the void, and it's just floating around, it's hanging out. And B is pointing to where that integer is in the void. And then if we were to let this function return, this integer that we've created right here, B, would still exist. and it will exist until our function, stack first in, first out. If you actually looked at the, heap is out in the wild. And the majority of stuff in programs is actually on the heap. We're just storing in constructors and destructors, so initializers and deinitializers in kind of Python terms. Basically, the thing people worry about is forgetting that this variable exists. So after we use b, like if the value b is pointing to is 3, do stuff. Once we're done with that, so yeah, to actually delete the memory and just have your function stop worrying about it, you'll actually need to call delete. So new to create it, delete to destroy it. And you just pass in b, and this integer out in the void, gone. No longer exists. So basically every time you call new, you have to remember to call delete when you no longer need that variable anymore. Pretty much. And that actually brings me on to the next point. So C++, relatively recently, probably inspired by languages like Rust and whatnot that does this for you automatically, has something called a unique pointer. So if we create a unique pointer to an integer, like this, and of course it's using templates, so it's a little bit scarier if you're used to Python, but standard library, make unique integer, so make unique pointer. And what this is it's a class allocated on the stack, and when this class is destroyed, it automatically calls that delete function on this integer pointer that we have passed to it. So if we wanted to return it from this function, we would actually have to call this move function that says, okay, we want to move C out of this function and into there. Otherwise, the pointer gets automatically destroyed. So this has a bunch of safety nets to make it so you don't forget to delete it because it remembers to delete it for you. And I use unique pointer a lot to just kind of hold the base pointers to stuff. But yeah, and then if you want several references to the same thing, you can actually use shared pointer like this. And then you have to use make shared, or you use make unique and then it gets upgraded to a shared pointer. I have been a college tutor before. I've not thought about doing a C++ course, but I have taught C and C++ at a college, so I do have experience. But yeah, so shared pointer, and I'm just using auto because I don't want to type this out again. But if we set this to that, this actually has an internal pointer to like a context of sorts that keeps track of how many shared pointers are pointing to the same thing. And when that drops to 0, then it automatically deletes the pointer. So it's a lot more complicated internally, but you can just copy this as many times as you want, and then when all the copies are deleted, it automatically deletes the thing in the void as well. I guess kind of like that. I'm actually not too familiar with how symbolic linking in file systems work. But I would assume it's similar. Yeah. They're just memory addresses. They're technically pointers. So it's not even that you're making a metaphor, it's that they're literally a memory address, but on a hard drive instead of an actively running program. Oh. Okay, that's a little bit more complicated. I thought it was like a shortcut or something. Yeah, no problem. I don't think I have the bot for that, but I mean, you can manually do it. Thank you. I do put some effort into making sure the the stream is watchable. This block, then when create condition, we pass in the condition. We pass in basic body block and false branch. And if we don't have an else body, we want to set this false branch to the merge block. Otherwise, false branch is equal to else And then, oh. Okay, so let's just create branch. Wait a second. Do I need to call load value? Let's test this out. So I know I reference a constant in here. So I need to take another look at this byte code, intermediate representation. There we go. All right. Oh, it just inlines it. Okay, so I don't get to see the... That is interesting that it inlines it, though. So that doesn't really answer my question. Oh well. In any case, I'm going to try not having a load value here and just hoping it always works. If end, if body, builder, create condition break. Ah, context. block. Actually, do I need to reference? I might not need to reference the block in the AST context, because where do I use this? When we create a new block. And that is the only other time we use it, because we use the builder for everything else. So I don't think we need to store block in the AST context. Now here, I'm gonna fix this real fast. In a function context, create AST, where are you? There you are. Since it's an overridden class, I might not actually need this to be alloc instance. I might be able to keep this as just value. There we go. All the code is happy again, except for this. So after we do this, context builder, set insert point to the merge block. Okay, so I need to actually pull this condition and actually do that before anything else. Alright, if we have an else body, then the false branch goes to the else block. So the conditional actually goes here. After all this, we set the insert point to be the merge block. All right. Oh. Okay, so for some reason it wants to insert this on the end of function. I'm just going to trust their judgment on that. Wait. Okay. Okay, that makes sense. So it's saying this could have created more blocks. So basically when getting a reference, back, we need to grab the current inserting block. The block that we're currently inserting to. Ramen is good though. Ramen is worthy. The phi operation. All I know about what SSA is, but what is the phi operation? To resolve this, a special statement is inserted in the last block called a phi function. This statement will give the definition. Oh, so it's just saying, hey, these are the... It's like a backwards reference. Got it. Got it. So we set the... So after emitting the body block is equal to context builder get insert block. And we also want to do this exact same thing after doing else. So false branch is equal to builder get insert block. Alright, so we then set the insert point to the merge block. So after we merge it back into this block, we create a phi operation. And phi does not stand for anything. It is just the Greek letter they use to define it. I think it might be for like mathematical union. Are they called functions? Not called operations. Mathematical concept called a union. For the mathematical concept of sets. Actually, I wonder if that is the source of it. So Greek phi meaning in math. Okay, it's actually the golden ratio. sets. Okay. So it's not actually a mathematical thing. It's a specifically compiler thing that they just decided to use the decided to use phi. It has to do something with set. Okay, no, that's still the golden ratio. They couldn't have just used like the union. Okay, whatever. I'm gonna stop nerding out about which mathematical whatevers they used. Okay, so after all of this, create phi. Oh. Get double type. LLVM context to phi, add incoming block, and we want to do the body block and the false branch. Yeah, for consistently, I'm gonna rename this to we're gonna rename this to true branch. Value equals. I actually have to set it to the value of incoming. Are we returning values from if statements in that language? All right. Value compute. Okay, what grammar are they using for this? Okay, they are using returns. So why are we returning the phi node from the thing? I guess it's just the check if it was successful, because that's how they're doing error checking. Okay. What exactly is this doing? It's an instruction used to select a value depending on the predecessor of the current block. Oh. Okay, I understand what's going on here. I don't understand it well enough to explain it, but I understand what's going on here. I don't understand why the tutorial has us returning the value, though, because I don't return anything from my if statements in my language, but in this language. So for the function code gen, well, that's function. C4, okay, prototype. That's the for loop. We're not worrying about for loops. I only have while loops. I haven't even attempted for loops yet. So is this find node just capturing all of the local stack variables and just automatically, like, any references that this block has to this block, it just automatically creates them or something? So we're not returning anything from the blocks. If it was like a conditional, the find node would make sense. Would it? Maybe I don't fully understand it yet. Create conditional break, set enter point to then, generate it, create a branch back to the merge. We then get the insert block, which is then value. Can you give me an example of what the coding language you're using as an example for this program looks like? Wait a second, they have a GitHub for this, don't they? They have source code. And I know this because when we go to the JIT one, we actually, they try to get out of showing you how the JIT compiler works, and they like give you a helper class to help you out with the JIT compilation. I was like, no, let me see the source code. I want to learn how this works. Okay, so for chapter 5, it's the C++. Do they not show the actual kaleidoscope? Okay, examples. Kaleidoscope. They don't give you an example of what the coding language looks like. They literally tell you how to make a parser from scratch. Wait. Aha! I was right! They are directly just returning values from here. See, no return statement, just returning the value. I don't need to create a phi node. We're not passing local values, temporary values from the branch. If I create a conditional, I will need to reference this. However, for now, no. No phi nodes for me. So for loop should be done. It should just work. So let's move on to the while loop. Oh, fine. We'll make the function definition manually. Come on, but I gave you a lot of RAM. A lot of RAM mean go fast. But no lot of RAM. So here's the example of what for loops look like. All right, we're going to basically completely ignore all the things to do with returning values from this. Don't need to parse it. I don't need to know how you parse the toy language. Ah, here it is. So we create a new block. Wait a second. Oh, never mind. I'm not going to worry about that. Make a new basic block for the loop header. Oh, so we're just using that to get the function. That's fine. Oh, hello. Welcome back. I figured out why the way that they were having, like, I figured out why the way that they were creating the if statement was weird. They have this thing called a phi node. And I was like, why are we returning a phi node from this if statement? If statements don't return anything. But it's because the toy language that they use in the tutorial actually does return values. And because it's a value that could be from either branch of the if statement, the data structure they're using to store the intermediate representation, DAGs, actually no, not DAGs, it's not specific to those. Anyway, basically in LLVM you can only ever assign to a value once. Memory locations don't really count. You load and store stuff to memory locations, so it's like local variables on the stack and pointers or whatever. You can assign to those multiple times, but anyway, for regular values you can assign only once, and since there's two different values you can get from the branch of the if statement, they had a phi node that combines them. Then they're returning the phi node. It's like, hey, this one value is actually this value or this value. But I'm like, ha, my if statements don't return anything. I don't have to deal with any of that. So we are now moving on to the while loop. And since for some reason, somehow their for loop in this toy language can't actually return values. I don't know if they're just like, yeah, basically immutable. Functional programming-esque. It's really easy to do optimizations if you have to create a new variable for every time you do an assignment, I guess. Hello, how's it going? Welcome to the madness. For loop. Code generate? Okay. It's PHI, phi, like the Greek letter. Basically, it's a way to tell the LLVM. It's a way to create an LLVM value that is one of two different values. So it's like combine these two values, treat them as one. Basically. Because of the weird data structure they're using that makes it weird to create it, but then really easy to optimize, is basically the idea. Okay. So going back to the while context. the body of the loop, and then we have the end of the loop. And we just create. And we're not going to actually. Do we? Okay, we do add this onto the end of the function because there's not. Well, yes, there is branching. It's only branching going back up to the top of the block, not branching between blocks. Okay. And of course, the example's all weird because they're trying to return values from a loop. We don't want to return values from a loop. And we don't explicitly define the end condition. I just want to pass in a condition, just like for the if statement. So I'm gonna do this whole thing again. And I might be able to just use the same code, maybe? So I'm not automatically creating a condition, I'm just using a condition. Okay, so it does use the same conditional branch that the if statement uses. I'm going to see if I can write this from scratch without referencing the tutorial. Builder, create. I might reference it for function names though. Condition, and if the condition is true, we go to the body of this. Oh, interesting. So we actually want to set the builder to start inserting into the body of the loop. So get insert block. No. We want to set the insert point, and we set this to the body because we want to loop back up to here and recompute the condition and then actually do the jump again every time we go through this loop. Wait, no. We need another block here. We're gonna call this just the header. So if this is true, we want to go to obviously the body, branch to the body. If this is false, we want to branch to the end of the loop. All right, see ya. So after this context, we want to set the insert point to the header, not the body, because if we set it to the body block, we're just gonna go true, reevaluate condition, true, reevaluate condition, true, yeah. Infinite loop. So we have 3 different blocks here. One of them is the header, builder, create branch. Then we want to jump back up to the header at the end of the loop. The context builder dot set insert point to the body. And then we want to do create the AST for the body of this loop. And then after we've done all the stuff we want to in the body, we create a branch back up to the header. Header goes through. Let's say the condition is false. Now we want to context builder dot set insert point end. So now everything after this loop will start inserting into the stuff after the loop. I think that handles loop. What do you mean this isn't never accessed? I pass it to a function that's accessing it. All right. Body and insert body. Create branch to header, and this looks correct. There's not much more to go. Except for native operators. And we don't handle those yet. We'll still be able to generate the bytecode though, because we don't actually try to link to them. We do still try to link to them. So the language, technically, yes, it is working right now. The version of it live on my GitHub passes all the tests and whatnot. However, I am working on refactoring it, so this version of it very much does not. I just lost my train of thought. Where are we? Ooh, assignment context. This is going to be fun. It's actually not going to be too hard. So just need to grab this assignment. Yeah, I've been enjoying LLVM so far. I was hesitant to use it before for reasons to do more so with my end use case and not with the actual library itself. However, I've recently had those concerns resolved, so I'm like, hey, we'll refactor it into LLVM, and I'm just like, huh, after writing a language from scratch for 6 months, using a library is actually pretty easy. I just have to learn, I'm having to relearn some of the more weird compiler concepts. I'd already been learning about like how the basic block structure and everything works because I got this compiler textbook I've been referencing while building the language before, but I hadn't really implemented any of that stuff yet. And when I tried starting to implement, I was like, I have to refactor everything. Might as well throw LLVM in instead of building it all from scratch. What am I doing? Right. Assignment context. We are creating the definition for create AST. You sly dog, you had me monologuing. LLVM value, L value. Yeah, let's create the L value first. My condolences. Web shit is very much not fun. What particular flavor of web shit are you having to deal with? Being subjected to. Oh joy, Docker containers. I don't even want to think about that. Here I am creating a coding language, not necessarily completely from scratch anymore, but still essentially from scratch. And even I loathe web languages. Let's see, assignment context. We have this as a okay, it's a statement. It doesn't need to return anything. Pointer. It's always a sad day when you have to add the first dependency, or the first actual dependency. Libraries to deal with stuff like JSON and whatnot don't count. Of course, you're using JavaScript, and JSON is literally JSON, JavaScript object style syntax. JSON is JavaScript, basically. I had an S there at the end. Wow. It is too late. But hey, I'm committed. I need to get this working. I mean, I don't need to get it working, but I told myself I'd get it done in 4 days, so we're getting it done in 4 days. We're on this is day 2. And we're mostly done with the syntax generation side, aside from native operators. We already have casting taken care of, which is nice. Ooh, very nice. The stack grows evermore. Okay, I have been doing this for like 5 minutes. Let's actually type something. Create store? Yeah, it's because it's load and store. What is volatile? Oh, is volatile like we use it a lot? I am not going to worry about if it is volatile or not. I feel like there's an optimization pass that would find that automatically. Yeah. Sandboxing and whatnot. Speaking of sandboxing, this is the scripting language that I'm building for my game engine. The JIT compiles code. Very secure. Much wow. I actually am going to put in decent effort to make it secure. But on the service level, yeah. Thank you for the follow. So my game engine, so we got Brane script, which is the scripting language, and then we have Brane engine, which is the actual engine itself. So basically I'm trying to build like a VR oriented engine that loads in the assets at runtime over the network. So basically, WebXR, but with a dedicated client and not on the web or using any web languages because I hate web languages. The definition, like my explanation of it changes every time someone asks. So, well, the way I explain it, the actual like construct of my mind doesn't. But yeah, the engine is very close to being minimum viable product ready, so I can actually like build apps in it. So it's like technically there are games running in the engine. Do they run efficiently? I don't know. Is the render pipeline really good? I don't know. It's 3D. I intend it to be like a VR based engine eventually, so like mainly for headsets and whatnot, with a little bit of crossplay thrown in, so it will have like probably some form of desktop input that like emulates a VR headset or something. Kind of. I think, is this all I need to do? Hey, parallax, man. So I think pointer is the value that we're assigning to. So yeah, pointer. Left value. I'm gonna throw a load value on that. Hey, but you see, when you add two 2D screens together, they like merge, and there's an extra like D that gets added in there. Oh. Okay. The 4-hour Cyberpunk Dark Synth mix did not end. It's just in a in a lull, it seems. There we go. Ooh, constants. These are going to be easy. And I'm so glad they're separate nodes. Oh. Pop, 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 pop. Indeed. Okay, so for this, it's just there we go. Create constant. Oh, let me actually. Okay, so we're going to okay, this is document context, good. I'm sorry, man. There's not going to be any native NFT support in this engine. Actually, I'm too sorry. I can't stop people from adding it in, but I'm not going to be the one to do it. See, I don't want to be a web dev, so of course I'm not a true web dev. Look at me, coding in C++. Not even Rust, it's C++. Raw. Oh, it exists. You could say that. I would feel very at home in the 70s writing assembly language, I will say that. Constant. We want. I guess there's only constant int, technically. So simple they were more complicated in some areas. But yeah. There were days when one person could basically memorize all the source code for an operating system. It's crazy to think about. Or one person would know what every single component on a computer does because they designed the motherboard themselves. One person. Indeed. So in the example, they only ever use floats, advanced precision floats. It just means that this template or whatever automatically detects the size. Don't want a constant floating point. And okay, that's a Boolean. We'll just have this be, wait a second. They do show me how to make a constant Boolean. In the loop, they just hard code the condition logic into here. Where are you? Aha. Compare one. Oh, right. Oh yeah, that's right. They only use doubles in the example. So the Boolean is actually a double. Is there anything more cursed than that? Using a double floating point value as a double. I mean, it's an example language, so like they're trying to keep it simple so you can learn how to actually use the thing, but constant floating point equals get dereferenced context, advanced precision floating point. Thank you for providing me with one more reason to absolutely loathe JavaScript. Oh, that's disgusting. But yeah, we're actually going to go AP. Our Booleans are going to be unsigned. None of this signed. Int. Integers? Wait. So they only have objects and floats. And that's all. All that brings... Why would somebody create... I mean, they did name it JavaScript after Java, even though it had no relation, just to get on the marketing buzz. Like, what did you expect the language to be like? So we're just going to statically What are you complaining about? Okay. So the problem... Value pointer, constant... Oh, we actually need to call a function. There we go. Now we're good. Alright, AP int. Show me your secrets. Oh, so this can only be a word or not a word. Wait, is single word? Word is 4 bytes on 32. I can never remember if it's a single byte. Not bit, byte, or yeah. 64-bit word, 8. Okay. Actually, I tabbed off of that now. I don't want that. Alt shift out, control shift. There we go. 8 bits. It's called a byte. 2 bytes together, 16-bit. Okay, so it's the size of integers word. Assign 64-bit value. Okay, I'm just going to use this constructor here. So AP int, only 1 byte. This is our value. Does that have... And signed as false by default. Yes. In the most literal sense, it was. All right, we now have the basis for constants. So now we do a character constant, which is literally going to be the same code. Behold, the exact same code. Actually, oh, character is one byte long. So now we create an int context. And integers in my language are always 32 bits, so... Wait, bits. Not bytes, bits. Advanced precision. So like we talking, this was going to be 1 bit. I mean, well, we have to load it into a register. So if we're going with bits and not bytes, that's 8. And let's see, that's character. So we also need to do it for this. And now for constant integers, this actually needs to be 32. And for float, nope. Okay, for floats, we actually use stant floating point and use AP float. And now we don't have to pass in the number of bits anymore. And then for, well, I don't have constant doubles. It should probably be double by default and not just 32-bit floats. But here we are. Ooh, strings. This is going to be a pain. I'm going to have to refactor how I handle strings entirely. Because the way that I currently handle strings is I would literally, in my scripting runtime, to load a script at a constant string in, what I would do is pass a pointer to a standard string class instance that was stored within the script class. So this is an instance of a loaded script in my old runtime, and all of the constant strings were stored right here. And the way that I handled strings in the old version of the scripting language is I would literally link all of the operators and whatever for like standard string just through the JIT runtime. So all it knew about string was that it was a pointer to an object called string. And then it would just link all the operators. Obviously, we're going to have to completely nuke that. But for now, I just want to get this to where I see intermediate representation by the end of the night. Meaning, assert false. Wait, did I already handle function call contexts? It would be amazing if I did. Ooh, look at all those errors that just disappeared. Very nice. What was going on here? Okay. So we place back this destructor. Enable value destruction context. Don't I have a... I do have a constructor for this. So I want to pass variable into here. I think I just had barely just added that in. Like on last stream, I think. Did I really already handle function calls? I sincerely do not believe that I did. Document context, function, call context. Oh, okay. I didn't. I just defined the function. All right, let's go through the pain of figuring out how a call works. And I also need to AOT value construction. Wait. There are still several things that I need to take care of. Two main things. One, the function call context. The other, defining local variables when we visit the struct node. Or not struct. When we visit the scope context. There we go, I remembered it. All right, let's see the pain that is calling functions. So do we just search the module for... Oh, it's that easy. And then context, func. Oh wait, no. So the function that we're referencing, signature. Seed module, that is the module. So when we get function, How do we handle overloaded functions, though? Alright, I don't trust this. So instead, context functions, because I remembered I actually defined that. Assert function iterator is not equal to context functions end. You want a vector here, not... Yeah, whatever my brain was doing there. Can you tell it's nearly 2 p.m. and my ability to function is rapidly deteriorating? Is that all? Apparently that's all. And I just click something. Okay. One last thing, I believe, and then we're done. And that is in scope context. Scopes are what we store the definition for local variables in. So this, before we create the AST for this scope, we actually need to define the values in this scope. We also need to push and pop the scope. For auto reference value in local var local variables context builder dot create alloc a of type context get LLVM type variable. Get Is that all I need? Apparently it is. We don't care about array sizes at the moment. And we're just gonna call this. Oh, I can actually embed the actual names for things. Oh, yeah. Var dot long ID. So this actually creates the variable. And next thing we want to do is context add value variable long ID. Actually, we know these are all local variables. They don't have scopes. We'll just do the straight identifier.text. Because they won't have namespaces. Okay, so we now actually have local variables. We define global variables. We don't have a way to link external functions yet, but we can do it implicitly. So, I'm gonna pull a funny. Which is if oh. And we will call that function. However, if the function is not defined, we pull a funny. And the funny is func is equal to context.module.get or insert function. So basically, if a function doesn't exist, we're just going to create one with external linkage. Function long ID with we need to do create function type, so control find function context, so we can copy stuff from here. archetypes, function type. Boom. I should be able to just pop. It just works, except for args. Because each argument is actually an expression, so arg return type pointer to return type. Why did I make that a pointer? It's too late. So we just generate a signature for this function with all of that. Get or insert function name, function type. Get or insert function. Where's the version with the lambda though? All right, we don't. So on global variables, there's a callback you can pass that makes it so you can just generate the. You can just generate the new function. Actually, let's look at this attribute list. Turn index, function index, first arg index. Okay, what are attributes? So I'm pretty sure one of these would be external linkage, but I'm too lazy to deal with that right now. So instead we're going to do it the right way. And that is in, well, function context. When we create the AST, if body create AST, I already handle it. Oh, that's great. So basically, oh, I don't handle it. Okay. If we don't have body, linkage is equal to LLVM function external linkage, and we want this to be the available externally linkage, not the external linkage, I think. Available for inspect. What does available for inspection but not emission mean? Ooh, there we go. Globals with available externally linkage are never emitted into the object file corresponding to the LLVM module. From the linker's perspective, an available externally global is equivalent to an external declaration. Okay, so available externally means the function is available to this module from an external source. This is external. Externally visible, meaning that participants in linkage can be used to... Okay. I was using this wrong. I'm very glad I found that. Because we don't want to use this. We want to use the external linkage. And this, available externally linkage. And then global. Getter insert global. Make global variable. Blah, 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 blah. Ah. External linkage, private linkage, and we want this to be the available externally linkage. And with that, let's just make sure that visit import. We also want to visit all the functions, and we can actually just create AST and they'll automatically detect that or will they? They won't. Dang it. Okay. Alright, function context. Time for me to steal your code again. Get function type. And we're gonna actually grab all of this. So for every function that we import into this script, we want to create a definition for it with the available externally linkage. And now we will actually link to all of the external functions. So theoretically, I should now be able to generate bytecode using this recursive function call, because all of the native operators I'm defining as regular external functions will just show up in the binary, and since, well, intermediate representation, and since we're not actually going to be compiling that yet, you don't have to worry about it. Just don't worry about it. It's all good. Don't worry about it. Okay. So what we want is this. All right, tests. Which one of you will be the object that we will use to test? Operator tests. Since, yeah. Actually, one last thing that I want to do. That is in, yeah, function context. What I want to do is there is a function to verify that a function is valid, I think. Somebody finally responded to me in the LLVM Discord. I was just asking some questions about kind of the security of, you know, the JIT runtime. And it turns out, yeah. So yeah, it looks like there's not the possibility of people throwing in function system calls into the bytecode, because you actually need to link the libraries like libc and whatnot manually to do that. And also, it keeps track of allocated memory, so if somebody just like memory leaks like crazy, and then I unload the script, it will actually clear up all of that memory, which is amazing. So while it won't be great for RAM in the moment, I can even write custom allocators for it, which means that I can manually detect, oh, this person's using a gig of RAM. Maybe nerf them. Yeah. Oh, right. So what is the verify function? Verify func is provided by LLVM. Oh, time to find the header that it's in. Verifier looks promising. All right, so now we verify the function. So we're just gonna assert this. Oh, reference. So this should catch if there's any actual compilation errors. So real quick, let's just try manually calling this. File context. what is the other type for the initializer? Module source. Test mod. And we want to grab this. So we print so right here, moment of truth, script, context, create AST. This function right here, very much a moment of truth. We call this, everything breaks, or we call it, and we get some very nice intermediate representation. Let's see if it even compiles. It does not compile. Okay, so I think we got past that error. Okay. We got past check compile errors. So we're good. The analyzation context should be fine. Let's see if this works. Oop. We got a divide by zero error of all errors. In one of my very old scripts. We'll just pull a C++ and make this 1 byte. However, I want to see what's triggering this. It's string, isn't it? It's string. Oh joy. Oh, we're not using string. And we're going to refactor all of that probably tomorrow. Actually implementing a data type in the scripting language. Okay, I was correct. So we tried to find a structure with no members. And let me guess, it's string? Brane script? Yep, string, because I just had it empty since we were just using it as a pointer to a standard string for now. Invalid address. Okay. I can work with invalid addresses. And this is one of the places I expected to get errors. Struct context, okay. I mean, struct context, that wouldn't be null. LLVM types. Can we not create empty structs? So it's array ref. LLVM type pointer. Let's just try compiling that again without an explicit array ref. Maybe if I manually pass in the length, it won't freak out about there being a zero size struct. Or use of undeclared. Oh. Okay, so that's getting inlined. We want this one. Data length, LLVM types. Can't be that it's just zero sized. I mean, that's like the only thing it could be, but data null. If we reserve one value, maybe it will allocate a little bit of data. Ha! That was the problem, is that the array had not allocated any data, so the pointer it was passing was null. Even though data type is 0, this pointer was still, you know, yeah. Invalid address. All right. Instead of going through all this trouble, instead, if LLVM types empty, else oh, here we go. We don't pass in any elements. We do, however, pass in the context. Oh. All right. Set name. Okay, so oh, I did a stupid. I incremented before instead of after. A function call with it. Wait. This shouldn't ever be null. How is it null? Who dares to find a null function? Okay, function call context. So those are arguments. Oh, parameter. Stitch and cast template argument. So we do check the how the hell did that properly cast? Oh boy, that is an abomination. Because this is returning expression context. So So cast context is actually equal to resolve cast. And we want to from so we're just going to delete this since we lost the pointer. And we will have an error here. Actually, we can just throw the cast error in here and it will do just nicely. Because the cast error can't cast this to whatever. So we should no longer be creating an empty function context there. We are still creating an empty function context somewhere. Come on. This is one of the last things. And that calls a resolve function call, which obviously resolves the function call. I have the same code here. Ah, pain. So I refactored this, but never actually refactored it. Ah! Alright, so if we do successfully cast this, then we just want to do that. Otherwise, we return false. And here we are, another null function. Diecast. Resolve function call is fine. I'm gonna find every single reference to this function. No. And okay. Correct way to use it. Incorrect way to use it. Incorrect way to use it. So we still have two. Okay. I knew I should have checked. That's my bad. I love how the actual cast operator is the last one that I fix. Alrighty. Null expression, that's what I want. What happens if I Valgrind this? We'll actually track the source of the null pointer. Yes, I know. I'm aware that there's a null pointer access error there. Alright, let's figure out the source of this function. So if we debug this normally, it's a function call context, obviously, called from inside of a return context. So we're returning from a function call inside of the function which function is this? Int 64 cast. So it's a cast context that's causing the error. So visit cast from so we are from a unsigned 64 to unsigned int. Okay. Is this a valid native cast? It should be. It is. So we return a native cast context. We now initialize. And we so the cast context that was returned is a expression context, obviously. It shouldn't be a function context. Void null. Should return this. Wait a second. I don't have any error checking there, I just realized. That was the problem. Assertion false failed. Float 64 to scholar begin. uint 32? Wait a second. So in here we got null. Float 64 to... Okay. Float 64. So look at this. We have all the external declarations for everything, including the string functions. Available externally, Brane script string. We externally declare all of these functions. So I may change it so we no longer externally declare them once we actually change it so that we don't need them. In fact, right now, if I delete them, we'd be fine. Unsigned int cast. Entry, nothing. So we just defined a bunch of empty functions. Cool. But we actually defined all the functions. And they all look semi-correct, which is good. And we didn't trigger anything. All right, cool. We can work with this. Function context, generate AST. Did I just forget to set this? And oh, it's because I don't print it after the fact. Chunky I-64 V32. Does this need a load instruction? All right, okay. So, okay, we do load the value. Interesting. Wait, it's a function argument. It's an unsigned 64. Unsigned 64 to unsigned 32. This should be the most standard cast in the world. Turn. So, I-64 V. I mean, this looks valid. has the correct type of linkage and everything. Among Us. Alright. Wait a second. This is double. I know how to fix this. I thought we might get this error, but, you know, I was expecting it. Maybe. Alright. Document context. Cast context. Create AST. So the problem is that... Ooh. We can only cast to 32-bit integers and from 32-bit integers to floats. So if we want to cast from 30-bit, from double to int32 should be fine. Alright, let's find one of these documentation. Oh, that's not what I wanted. Loading point, to unsigned int to output to, wait a second, to unsigned int, and this is a signed integer. Unsigned int to unsigned int. Uint integer to signed int to signed int. Signed int to floating point. Signed int to floating point, unsigned to floating point. So we have a double of type V. To unsigned int. Takes a value to cast, which must be of scalar or vector floating point value, and a type to cast it to type, which must be an integer type. If type is a floating point, it must be a vector integer type with the same number of elements. TI. Okay. Floating point to signed integer. Oh, wait, that's right. The actual registers don't actually store sign. I was getting freaked out over nothing. And this should be one of the only casts that work. Am I missing some, like... We do have a return value. Okay, we return function. Floating point types. Okay, so it can be any of these types. Must be an integer type. 32-bit, really big. Okay. return type value. This should be fine. Wait a second. Was the problem that I didn't have an identifier for it? Arguments null. Interesting. Number of argument. Okay. Number of arguments 2. Linkage type 1. LLVM link. Ah. Oh, that explains it. We want the functions long ID, not the linking context. Why does the link? Oh, I'm not gonna worry about it. So we got all the way to multiply. 2 unsigned integer 64s. See if return is for debug off. Wait a second. Okay, we are calling Brane script operator. I-32, I-32. Available externally. Wait a second, do I have to do it differently? Is there a different calling convention? No, this is the wrong create call. This is the call. Okay, is it just sorting them in a different order or something? Okay, so it's not anything I'm doing with that, it's just sorting them differently. So there's a problem with how I am calling things, I guess. Wait a second. Is there a finalize call? Wait a second. If there are no errors, the function returns false. If an error is found, who writes a... Oh, wait. I'm done. I just... Let's have it error out when a function is fine instead. Oh joy. Okay, instead of verify function, we're gonna just attempt a verify module. Oh. Interesting. So the module verifies, but oh. I'll take it. So yeah, apparently verify function doesn't always. Maybe it wasn't fully verified because it wasn't like linking to stuff, or I don't know. Alright, I'm gonna copy paste some stuff. Moment of truth and all that. Can we actually compile this code? I don't want Visual Studio Code. Why did I open that? We want this. LLVM orc and the ASM printer and the ASM parser. Oh, it's this stuff we want. Okay. So basically the thread safe modules are CC module, CC LLVM context. And the function I'm going to test is, I have not implemented that yet, so I'm not going to test it. Oh, it's probably going to error out because we don't have the external functions. It's probably going to error out. Well, actually it is, without fail, because we're looking for a function that does not exist. So I would want to delete this. So it did compile? Huh? What? I thought with all of the non-linked functions it just wouldn't. Let's attempt. Oh wait. Okay. Let's try calling one of the functions and see if the JITted functions actually work. Alright, let's select one. The double adding function, since we already have that. See, this should be the mangled version, so this should just look up. We don't actually have a function for adding doubles, though. Not linked, at least. Symbols not found. Operator plus 28. We should call it cast instead. That's a lot more likely to work. Because the function is actually linked correctly. Wait, is Oper 29? Is this one? We literally just tried to find an external, yeah, available externally. That's on me. Dumb. Stupid. Let's actually grab one of the functions defined by the thing. I want to do casting a double to an int 32. Assigned int. This looks promising. We look up a symbol that actually exists. And then this is a double to an int. And it should return 4 if everything goes well. Did it not find it? Oh, does it mangle the names differently every single time? Ugh. Okay, how do we mangle accounting for operators? Mangle symbol names, and then uniques them in the context of an executions. Okay, I wonder, since technically it's already like doing its own sanitization of the name, I wonder if I could include the operators as part of the address. I mean, not the operators, the arguments, just as a string. So create so in function context, create AST, create, instead of having the ID be the long ID, should do the full signature. And that way I would actually be able to differentiate between overrides on the back end. And I also need to do this in the import context. And now, in my tests, we will be able to mangle this, int cast double. Symbols not found in cast double. Int cast. There it is, right there. Did I spell it wrong? Tests int cast double. Tests int cast double. Wait a second. I'm calling runtime remove before ever grabbing it. And it's still not finding it. Come on. Failed to materialize symbols. Alright, so we found it, but we have linker errors. I see symbols not found. Also interesting note that it lazy loads stuff. Not sure I'm too big a fan of it lazy loading. Oh well. I got as far as I wanted to without actually implementing native operators for all of these. We're not going to get this done by, well, it's 4 a.m., so I should go to bed. But I consider this a very successful stream. Thank you for those who watched, and I'll see you next time.